Welcome back to Code Meets World. Today we're going to be looking at a problem in the one-dimensional dynamic programming category, which is the min-cost climbing stairs. So this problem says you are given an integer array, cost, where cost I is the cost of the ith step on the staircase. Once you pay the cost, you can either climb 1 or 2 steps. You can either start from step with index 0 or 1. Okay, so you could start at the bottom or the first step. We need to return the minimum cost to reach the top of the floor. So this is extremely similar to our last problem, which the video is linked at the top if you'd like to take a look at that. But in the last problem, we pretty much knew we could take 1 or 2 steps at a time, and we had to figure out how many steps, how many distinct ways we could get to the very top. This problem is a little bit different, but similar. So let's go down to the whiteboard and let's talk about it. So this actually sounds pretty fun. So it's like a game, sort of. So let's look at these examples. So if we have the first one, which is 10, 15, 20, the answer should be 15. So let's look at the rules again. You're given an integer array cost, so that's what I have here. This is cost. And these are the 10, 15, 20 is the cost of step 1, 2, and 3. So it says once we pay the cost, we can either climb 1 or 2 steps. We can start at either the first or the second step, and we need the minimum cost to reach the top of the floor. So what I'm assuming the top of the floor means is not 20. That's not the top of the floor. The top of the floor would be like 1 step further than that, because if you got to the 20 step, you have to pay to then move up to the next step. That's my assumption here. Okay, so if we can start on either the first or the second step, I guess I would want to start at 15 and then take 2 steps. 1, 2. So then our total cost is just 15. And yeah, that's the solution. You'll start at index 1, pay 15, and climb 2 steps. The reason that's the best is because if we started at 10, for instance, say we started at 10, we have to pay the cost, so that would start with 10. Then we could either jump 1 to 15 or 2 to 20. So we'd probably want to jump 1 to 15, pay the cost, then we could jump 2 to end. But that gives us 25. And we could also start at 15, the second step. And instead of jumping 2 steps to the end, we could just jump 1 step, pay the 20, and then jump another step to finish. But that would equal 35. And of course, I guess there's one other option, which would just be starting at 10, jumping 2. So 10, jumping 2, paying 20, and then jumping 1 to finish, but that gives us 30. So of all of these options, the best one is 15, starting on the second step and then jumping 2. Okay, just to make sure I understand this, let's also just look at the second example. So I will write it out. 1, 100, 1, 1, 1. This is pretty cool. But we can solve this with dynamic programming. I'm not sure how we're going to do it yet, but it's going to be super interesting. So this is a neat example because if you look here, we can only hit the 1s, basically. So we could start at the 1, jump 2. We could jump 2 again, jump 2 again. Now notice on this one we went and just jump 1, and then we could jump 2, and then finish. So that's 1, 2, 3, 4, 5, 6. And that's the same as we're supposed to get. Okay, great. So how do we want to solve this, I guess is the question. Let me look at this smaller example. What I genuinely think we want to do is pretty much exactly what we did in the last problem, but instead of keeping track of the number of distinct ways to get there, so instead of adding them together, so remember last time, and every time I calculated something, I basically looked at how many ways were there to get to each step and then added them together. So if I wanted to know the maximum number of ways to the top, if I was trying to find the maximum number of ways to get to the top, I looked at the maximum number of ways to get to step n minus 1, and then I added that to the number of ways to get to step n minus 2. So what I think I need to do here is calculate, and again, using dynamic programming, I need to calculate the minimum cost to get to every single step in the staircase. And the way I can do that is by finding the minimum, so to get the minimum cost of getting to step 20, I need to calculate the minimum cost of getting to step 15. I need to calculate the minimum cost of getting to step 10, and then I need to take the smallest of those two values. Does that make sense? Because I know that I can get from step 10 to step 20. I know I can get from step 15 to 20. So the minimum cost to get to 20 is always going to be the minimum cost of getting whatever is smaller of the two values of the two steps that precedes it. And this holds true for any single step in the staircase. So min for step n, and this is cost, minimum cost, is the min of n minus 1. Actually, it is the min. It's the minimum of two values, which is the min of n minus 1 and the min of n minus 2. I think that's the formula we're looking for here. So let's go to the code and give this a shot. Okay, so let's go ahead and write up a solution here. Again, I think it's going to be very similar to the last solution. So because this is a dynamic programming problem, we know that we're going to need a dictionary of some sort. And I'll call that min values and just make that empty. Then I'm going to have a helper function. Why don't we call it get min value? And we can set that equal to, or we can allow that to take in the value of the step that we're on, or the value of the step that we want to get the minimum value for. And the first thing we're going to do is, just like the last problem, if n, whatever we're looking for, is already in min values, then that's easy. All we have to do is return min values for n. And again, this is what makes it dynamic programming, because we will encounter situations where we will have to use a value, we will need the min value of, say, step 6. And so we've already seen it and we've already saved it. So that saves a lot of time in the algorithm, so it doesn't have to continue doing recursive calls that it has already done in the past. So then last time we also had a base case. If n was 1 or 2, we just returned 1 or 2 because that was the number of ways to get to those steps. In this case, I think it's similar, but we can just say if n is 0 or 1, we just want to return the cost that's in the array, because there's only one way you can get to step 1. I guess there's 2 ways you can get to step 2, which is to go to step 1 and then jump 1 to step 2. So that means if n there's really only one thing I have to calculate here. If n is 1 for the first step, and the reason I'm not doing 0 is because I'm going to pass in at the end here, this is important to note, get min cost, value. I should change it to cost. Get min cost. Because I'm going to say get min cost the length of cost. And I'm not going to say -1 like we usually do for array indexing. I'm going to say the length because we don't want to go to the last step. We want to know the cost to get out of the array. So going 1 past the top. So because of that, I'm going to basically 1 index the whole thing. And so if n is 1, I'm going to return the cost of 0. Is that right? I think that's right. We will see later if that is right. Then what do we do? So then this is where last time I just added the number of ways to get to step n-1 plus the number of ways to get to step n-2. So in this case, I think what we want to do is say that min values n. And again, I'm going to change this to cost. Sorry for changing the variable names, but I think it's important that it's readable. The minimum cost to get to any step n, if we haven't already calculated it, because if we did, then we already returned it. The min cost to get to any step n is the minimum of getting to steps n-1 and n-2. So it's the minimum of get min cost of n-1 and get min cost of n-2. So we get the min cost to get to the previous step, get the minimum cost of 2 steps previous, and then the minimum of those 2 values is the minimum cost to get to step n. And that's true because we can jump from either step n-1 or step n-2 to step n. So whichever of these 2 we can get to more cheaply in terms of cost, that's the one we want to pick because that will be the min cost to get to this final one. Except we're missing one piece. And if you are thinking, hey, you're missing something, you're exactly right. Because we also have to add the cost of the step that we are jumping from, if you will. So we could say min cost n equals min cost of n plus the cost of n. And I have the wrong, no, that's correct. Yeah, min cost n is whatever it is plus the cost of being on the step, because once you get to a step, you have to leave it in order to continue on, so we need to add the cost. Though we only want to do this if n does not equal the length of cost. Because if we do this for the case where n is greater than the last index of the array, we're going to get an error. So we want to avoid that case. And once we've reached the final step, we don't need to add any cost because there is no cost of not the last step, but the top of the staircase. Okay, so we have all of this. We need to have some return values here. Same here, we need to return the min cost of n. And everyone, I think I have this wrong because the min cost to get to step 1 is the first value. The min cost to get to step 2 should be the second value because I forgot that you can start on step 2. So if n is less than 2, we should just be able to return the cost of n. I think I was overthinking it with this indexing thing. So let's give this a run. Oh, you're kidding. That actually worked. For both the test cases. Let's submit it. Cross your fingers. Amazing. Wow, I can't believe we got that on the first try. I was not feeling confident about that solution. Why isn't this showing me? Okay, there we go. Oh, why is the runtime so terrible? I'm a little surprised that it's not better. I don't know, sometimes with this website, your code is actually decent, but then it runs super slowly when you actually submit it. And so maybe this is a little bit better than that is telling us. But I think this makes a lot of sense intuitively. And again, that's my only focus, to write code that makes sense. Not necessarily the fastest, but the most readable. And so, yeah, I hope you enjoyed that, and I will see you soon for the next video.